We were talking about how do we use variables in Java, and I've talked about that it's a two-step process. First, you have to declare a variable, only then you can use it. That means you cannot use an undeclared variable in Java. You already saw that. Now, let's say we wanted to do some more stuff with variables, like let's say you have a float or a double variable here. For example, I'll just call it double D, and then you assign the value that is 567.90 to it, and then you want to, for example, you have a requirement of putting this D into an integer variable, right? That is, these are of different types, guys. And obviously you might be wondering, why would I do it in the same program? And you're right. But generally, I might require it to be passed, this double D, to a particular method that takes an integer, or vice versa, right? So I'm giving you an example here. Let's say my integer variable is called I, and I'm saying D. Now in Java, that is an error. And Eclipse will tell you, see, it says, you hover on this, it tells you type mismatch cannot convert from double to int, right? So the same program, if you would have done that in a language like C or C++, it would have worked, and the I would have held the value, I would have held the value that is 567. 0.90 would have been truncated, guys. But Java, obviously the era we live in, points hold a advantage. You have two guys, and the first guy, for example, has got marks like 99.75. The other one has got 99.25. So the 99.75% guy gets the admission in a particular university, but the other one doesn't. And that tells you the value of decimals or precisions nowadays. And that's why the compiler here is generous enough to warn you, that is, you cannot do it, right? So, but you tell the compiler back, all right, my friend, thank you for reminding, or thank you for alarming me about this problem, but I want to go ahead. The compiler tells you back, all right, go ahead at your own peril, at your own risk. And that risk in Java is called as typecasting, right? Variable typecasting, guys. And that is, you can do it like this now. I can put it to int, right? And see, now the compiler, your friend, is happy. What you're doing here is you're saying D is of type double, right? Until now you have the value 567.90. You are typecasting, converting it into an integer. Here the value remains 567 as an integer, and you're putting it into a variable of type integer. The compiler is happy, and now when you try to print it, you'll get the value that is 561 only. I'll run this, see, that is what happened. Otherwise, an error, guys. So this is what I call as explicit typecasting. Okay. And you would have to do explicit typecasting anytime you're putting in a value of a larger data type into a variable of a type which is of a smaller data type. Like from double to int, like we did, from float to int, from long to short, for example. Right? All of that is called narrowing. And whenever you're doing narrowing, you have to typecast, guys. The other way around, see, is, for example, now I want to put this value of int into a float. See, I'll say float f I, and this works. This is not an error. Although f and I again are of two different data types. But why does this work? Because a float can always take in a value from an int. Right? In the sequence of their hierarchy, float is a larger data type than int, guys. It can always take it. And then what you're going to get here is 567.0. Say we run this. See, I'm still printing I. I'll print F now. Yeah, 567.0 on your screen, guys. Right? But make no doubts about it. Here as well, there is typecasting happening, but the only difference is it is being taken care automatically for you, right? And that is, this line is interpreted still like this. Right, and this is what I call as implicit typecasting. That is, you don't have to do it. You can technically, but why would you? Because it's being taken care of automatically for you guys. Implicit typecasting, right? The Java system takes care of it automatically for you, right? You don't have to do it. And this concept is whenever you're trying to do widening, that is from a smaller data type to a larger data type, that is called widening. And in terms of widening, we do not need to put in the cast. It is being put for us automatically every time we do it, right? That is about explicit typecasting and implicit typecasting, and when you need to put in the typecast and when you don't, guys. For narrowing, that is the simple rule. For narrowing, we always need to put in the explicit typecast. For widening, we don't need to, guys. I'll see you in the next video.